Hello, my name is Jackson Lanier, and this presentation will cover my ideas on predicting weather with machine learning. First, let me set the stage for why I'm looking into weather prediction. ClimateWins, a fictitious European nonprofit created for the purposes of this project, is concerned with our future in relation to climate change and, more specifically, unusual and extreme weather events. Their concern has spawned a project that aims to identify weather patterns outside the regional norm in Europe, determine if unusual weather patterns are increasing, generate possibilities for future weather conditions over the next 25 to 50 years based on current trends, and determine the safest places for people to live in Europe over the next 25 to 50 years. Taking action towards ClimateWin's objectives, I've created 3 thought experiments centered around using machine learning algorithms to analyze and predict weather. I'll briefly discuss these experiments before going into each experiment in more detail. First is the idea to use random forests to assess the most impactful variables in current weather conditions. Specific locations, such as regions or cities, can be targeted. This would require the use of current weather data measuring variables like temperature and precipitation. Second is the idea to use convolutional neural networks, or CNNs, to predict short-term weather conditions. These predictions could focus on unusual and extreme events. This experiment requires the use of weather images like satellite images of temperatures or radar images of precipitation. The third idea is to use generative adversarial networks, or GANs, to create synthetic and future weather data. Data generated by GANs could be used to make predictions as well as train other models. As with the CNN model, this would require the use of weather images. Before I explain each thought experiment in more detail, it's important to understand some basics of machine learning models being discussed. Random forests are a collection of decision trees that measure the impact of individual variables in determining an outcome. Combining the power of many decision trees helps identify the importance of specific features, such as determining whether temperature or precipitation is more important in predicting pleasant days. The next model, convolutional neural networks, or CNNs, are inspired by neural connections in our brain's visual cortex. They process data through a series of hidden layers, which allows the model to learn about specific features which make up the data. CNNs can process images which could be useful in predicting future weather events based on images of Earth's weather. Last are generative adversarial networks, or GANs. As the name implies, GANs generate data by pitting 2 neural networks against each other. One neural network generates new data based on actual data, while the other network tries to determine if the generated data is real or fake. This back and forth can result in the generation of realistic data, including images. This could be useful in creating realistic satellite or radar images of weather patterns. Now I will discuss each thought experiment in a little more detail. The first thought experiment involves using random forests to assess the most impactful variables in current weather conditions. The main goal with this experiment is to identify the most important variables in determining specific weather conditions. The example on the right is from a random forest used to determine that maximum temperature is the most important variable in determining pleasant and unpleasant days in Madrid. This idea could be applied to unusual weather events, such as heat waves and flooding, and could target a variety of locations throughout Europe. In order for this thought experiment to work, up-to-date data measuring a variety of weather conditions, like variables listed in the image, would need to be recorded by or provided to ClimateWins. The second thought experiment involves using CNNs to predict short-term weather conditions. The idea is to feed the CNN model either satellite or radar images of historical weather conditions that span a length of time, allowing the CNN to learn specific features related to different weather conditions. Once the model is trained, it could be fed real-time or recent images in order to make predictions on weather conditions in the near future based on what it's learned from historical images. Predictions on short-term weather could be measured against historical events to help ClimateWins determine if there is an increase in an unusual weather pattern. When testing and training the CNN model, validation datasets should be used. This exposes the model to never before seen data and is important for measuring the true accuracy of the model as shown in the graph on the right. This thought experiment would require historical images for training the model and present-day images for making predictions. The third and last thought experiment uses generative adversarial networks to create synthetic and future weather data. This idea takes advantage of the model's ability to create by providing the model data on current weather events, such as satellite and radar images, in order for the model to generate similar images that represent future events. One driving factor behind this idea is the potential usefulness in generating future weather scenarios to help in achieving ClimateWin's goal of generating weather possibilities in the next 25 to 50 years. Similar to ideas in Experiment 2, this experiment could use historical images of weather to train the model. Images could include general weather patterns as well as unusual events, which could allow the model to generate data that recreates the weather patterns surrounding unusual events. An additional feature of this experiment is using generated data in the training of other models. For example, if the GANs creates images of potential future weather, those images could be fed to CNNs to process their features. As with Experiment 2, this experiment would require both current and historical weather images. The images on the right provide context for this thought experiment. The top image shows actual wind and temperature measurements of Earth, while the bottom shows an image generated by a GAN. To summarize this presentation, I'd like to provide a few recommendations to ClimateWins as well as discuss some potential next steps. In order to achieve their goals, I believe ClimateWins should begin by using random forests to identify impactful variables in current weather conditions, focusing on unusual weather events. While performing this analysis, ClimateWins could begin collecting both historical and current satellite and radar images of weather for use in training a CNN model. Eventually, they can use the CNN model to predict weather. ClimateWins can also take advantage of GANs to generate images of future weather events and the conditions that accompany those events. ClimateWins should consider optimizing machine learning for higher accuracy. For example, when using CNNs, either independently or within GANs, Bayesian optimization will iteratively test and search for the model's best hyperparameters. Last, I have a few ideas for ClimateWin's next steps. I think ClimateWins should try combining the power of all three thought experiments. For example, as previously mentioned, weather images created by GANs could be fed to an independent CNN model for processing, allowing the CNN to identify specific features of the generated data and predict additional data based on the generated data, which could then be fed back into GANs. This feedback loop could help ClimateWins predict weather far into the future. Similarly, random forests could be used to identify impactful variables in generated data, which could be compared with impactful variables in real data, potentially aiding in weather conditions. ClimateWins will need to dedicate attention to assessing the usefulness of each model. I believe CNNs have the most potential for achieving ClimateWins goals. Their versatility in processing data types combined with their ability to be optimized for accuracy puts them high on the list of machine learning models. ClimateWins could also improve the use of GANs by first focusing on CNN models, then implementing CNNs in GANs. With that said, there is no perfect model for achieving ClimateWins goals. They will likely need to use a combination of models and be open to the use of new models, since the world of machine learning is ever growing and improving. As ClimateWins learns to harness the power of machine learning, they may be able to analyze both short-term weather patterns and long-term climate conditions, providing useful insight into the direction of our planet. Thank you for viewing this presentation. If you have any questions or would like to discuss this project further, please send me an email. Additionally, please check out my GitHub for a repository on this project containing the Jupyter notebooks used in my analysis, as well as repositories of my other projects. Last, I'd like to thank SlidesGo for providing the PowerPoint template used in this presentation.